So question B from question 1 of the 2008 Scholl paper, Physics. Discuss how diffraction and the photoelectric effect demonstrate the wave and particle nature of light. So there's two parts to this, just looking at the general structure of the question. We've got to look at diffraction and how that demonstrates the wave-particle nature, and the photoelectric effect, how that demonstrates the wave-particle nature. So I would start off by looking at diffraction. Okay, and the idea with diffraction is that if you have a gap or maybe a series of gaps, there's 2-point source gap. If light is a wave and it comes in this way, okay, like so, you get new effective sources coming out from here, and they will interfere. Okay, so these points are points of constructive interference where the crests are meeting crests, and you have antinodal points. So the whole point of diffraction is it shows the wave nature due to interference. Okay, if it was a particle, here's a particle, that's just going to pass straight through. Nothing exciting would happen at all. Okay, so that's how diffraction demonstrates the wave nature of light. It doesn't demonstrate the particle nature of light because of this. How does the photoelectric effect demonstrate the particle nature? In this case, the photoelectric effect is all about light shining onto some sort of metal, and electrons are emitted. So light hits it, electrons come off. There we go. And you can cause that to conduct. So the classic experiment is you have light shining on a photocell, and I always forget which way around they're going for this. It's not how you would expect it, but electrons are jumping off, and there's two ways I look at it, and I always forget this. I'll double check, but I'll just tell you the two ways. One is this is a really good sized surface for absorbing a lot of light, so that it can then make the electrons jump off, and they would go onto there. So light goes in, electrons come off. The other option is if light strikes this pin, this shield is a good place to catch the electrons, because it's quite large and curved. I'll just double check the direction that goes for you. Okay, so I've just confirmed that this is my diagram here is correct. Collector. Electrons are going this way. So electrons come out of the surface and they get hit by a photon of light at the right frequency, and they jump out and they conduct electricity. Okay, so how does the photoelectric effect demonstrate the particle nature of light? Well, it is because light of a very particular frequency will cause the electrons to jump out. I guess if you were trying to compare this to a wave, if it was a wave striking it, it would have to build up a certain amount of energy before the electron could jump out, but because it's light striking at a particular frequency, it makes the electrons jump out. And here's actually a good point: the electrons have a particular kinetic energy, which is related to the energy of the light. So it's kinetic energy of electrons. I'm having a dyslexic moment. Electrons. So the kinetic energy of the electrons is related to the kinetic energy of the light. There's a small loss of energy due to the amount of energy it takes to get that electron to jump out of the metal, but then that kinetic energy is equal to the remainder of that. And yeah, as with light, that's a particle thing. That shows that light has a particular energy, and I guess that's the photoelectric effect. That explains how we answered the question above, how diffraction and photoelectric effect demonstrate the wave and particle nature. Yeah, exactly. So if this was a wave, you wouldn't get this effect. You would have a build-up of light, or the intensity of the light would affect it, but the intensity doesn't affect it. It's just the frequency.